Hi, welcome to Send to Print. Today we're going to model a hinged box with a snap fit lid in under 10 minutes. This is a fully parametric design, so you can easily tweak the dimensions later to fit your needs. Let's get started. Before we start modeling, let's look at the rough sketch I drew for the box. We'll enter these dimensions into the parameter table so we can easily reference and adjust them later. Click Modify on the top toolbar and select Change Parameters. First, box L for length, 50 millimeters. Box W for width, 40 millimeters, and box H for height, 30 millimeters. Then add box wall for wall thickness, 1.5 millimeters. And finally, hinge D for the hinge diameter, 6 millimeters. Right-click the root directory in the browser and select New Component. Let's rename it to Box. Click Create Sketch and select the XY plane. Use the Rectangle tool, choose Center Rectangle, and draw from the origin. Enter box L for the length and box W for the width. Finish the sketch. And let's rename it to Box. Press the shortcut E to extrude. Set the direction to symmetric and enter half of box H. By doing this, the box is perfectly symmetrical across all three standard axes, which makes it much easier to use the origin planes as references later. Go to the toolbar and select Split Body. Select the cube as the body to split. Then for the splitting tool, select the XY plane. Hit OK. In the browser, rename the two resulting bodies to upper and lower. Don't skip the naming process. It might feel like a chore now, but it'll save you a ton of time as the model gets more complex. Select the Shell tool, hide the lower body, and select the bottom face of the upper body. Enter Box Wall. Use Shell again. And select top face of the lower. Again, enter Box Wall. Just like that, the basic structure for the top and bottom of our box is done. Now, let's look at the hinge design. A common way to do this is with a long, continuous pin running through a hole. However, for 3D printing, that requires long bridges, which can sag and cause the hinge to seize up. Today, we're using an optimized approach. Instead of a full-length pin, we'll design two small protrusions at the ends. A depth of 3 millimeters is plenty to keep it secure, considering the limited deformation of the plastic, and we'll taper these protrusions at a 45-degree angle so there are no overhang issues during printing. Click Create Sketch and select the XZ plane. Go to Create, Project, Include Project. Select the vertical outer edge of the lid and press X to turn it into a construction line. Use the Circle tool to draw a circle with a diameter of hinge D. This is our hinge outer profile. Use the Offset tool to offset it inward by 0.8 millimeters. This inner circle is the cross-section of our pivot. Now, use the Line tool to finish the hinge profile. Snap to the tangent point of the circle and press D to use the Sketch Dimension tool. Set the angle to 45 degrees to keep the overhang 3D print-friendly. Draw a line as a reference and add a horizontal constraint to it. Press the shortcut X to toggle it into a construction line. Mirror this line to the other side and close the profile with a line. Press D again to set a 0.5 millimeter gap between the edge of the circle and the inner wall. At this point, check if the sketch is fully defined. You'll see a small padlock icon on the sketch in the browser. If your lines are still blue, it means it's under constrained. We want it fully defined, so the logic is locked in. That way, if you change the box size later, the hinge won't break or move unexpectedly. Finish the sketch and rename it to Hinge. Press E to extrude and select the hinge profile. For start, choose Object and select the outer face of the box. Enter box L divided by 4 for the distance. And set the operation to New Body. If the hinge sketch disappears, just toggle it back on. Press E to extrude again. This time, select the inner circle. Again, set the start to object. Select the face we just created and enter 3 millimeters for the distance. The taper angle to minus 45 degrees, the operation to join. Make sure to hide the upper and lower bodies first to avoid accidental merging. Use the mirror tool under Create Panel, select the body we just made, and choose the XZ plane as the mirror plane. Now we have symmetrical hinges on both sides. Click Combine. Set the lower box as the target body and the two hinge bodies as the tool bodies. Set the operation to join and uncheck Keep Tools. Now they are all merged into the lower body. For the lids part, hide lower body, show upper, and press E to extrude the hinge profile. Set the direction to symmetric, distance to box, L divided by 4, and operation to join. To get a better look, let's go to Inspect Section Analysis and select the XZ plane. You can clearly see the overlap here. Click the Combine tool. Set upper as the target, lower as the tool, set the operation to cut, and make sure to check Keep Tools. Now we have a perfectly fitted hinge with no clearance. Press Q for the Offset Face tool. Hide the upper body. Select the contact faces of the pin and enter -0.2 millimeters for the clearance. The hinge is now complete. Let's move to the snap fit design and see how it works. When you press the lid down, the cantilever structure deflects slightly, allowing it to slide past the small protrusion on the inner wall. Once it clears that point, it snaps back into place, locking the lid down. That's where that satisfying click sound comes from. Click Create Sketch on the XZ plane. Go to Create Project, Include Project. Select the inner wall. Press X to make it a construction line. Draw a right-angled triangle. Press D and set the angle to 45 degrees and the height to 2 millimeters. This is the fixed catch on the lower box. Next, draw the hook shape. Use a parallel constraint and press D to add dimensions until it's fully defined. Finish the sketch and rename it to Lock. Let's model the catch on the box first. Press E to extrude, set it to symmetric, and for the total length of 8 millimeters, enter 4. Set the operation to join so it will merge with the lower body. Now for the hook on the lid. Hide lower, show upper, and press E to extrude the hook profile. Again, symmetric 4 millimeters, and join it with the lid. Press Q for the Offset Face tool, select the two angled faces of the snap fit, and enter a clearance of -0.1 millimeter. I'm using a tighter tolerance here because we want a secure, firm lock that doesn't feel wobbly. To make it slide smoother, press F for the Fillet tool. Select the edges of the catch on the lower box and enter 0.5 millimeters. Do the same for some edges on the lid. Finally, let's add a tiny 0.2 millimeters fillet to the inner corner of the hook to reduce stress concentration. And that's our locking mechanism done. To make it look better and avoid elephant's foot during 3D printing, click the chamfer tool. Select the top and bottom faces as well as the side edges. And enter 1 millimeter. Looking great. But to get this ready for the build plate, press M for the Move tool. Select the lid, set the move type to rotate, and pick the hinge axis as the pivot. Rotate it 180 degrees. This is our printing orientation. You could also use the joint tools if you want to assemble it and test the motion in Fusion 360. All right, the modeling is complete. To quickly verify the design, let's open the parameters table. Let's shrink it down. Change box L to 20, box O to 15, box H to 20, and box wall to 1. Now we have a tiny version of our box. Notice that the hinge and snap fit parts didn't scale down because we used fixed dimensions for them. This model and the Fusion 360F 3D source file are available on MakerWorld. You are welcome to download and check the source file. Through this file, you can clearly see every step of the modeling and the parameters I've used. Okay, send to print. After about 15 minutes of printing, here it is. Ridiculously small, but still fully functional. The hinge works perfectly, and the snap fit feedback is super crisp. I'll give this one to Thumbelina later. I also tried reducing the hinge clearance from 0.2 down to 0.1 millimeter. With the tighter gap, the friction increases, allowing the lid to stay open and hover at any angle you want. If you're looking for that premium feel, definitely try playing with that parameter. Okay, if you found this tutorial helpful, please hit the like button and subscribe for more 3D printing designs. Let me know in the comments what should I model next. Thanks for watching, and I'll see you in the next one.